Welcome to Easy Maths. In this lesson, we're going to focus our attention on the radian measure, in which we're going to attempt to define what it is and use that concept to attempt some questions on conversions of angles from degrees to radians and vice versa. So let's turn our attention now to the radian measure. Let me say that angles can be measured by degrees and or radians. We're used to degrees, but they are also measured using radians. A radian is normally an angle subtended by an arc length that equals the radius of a circle. And that means if we have a circle like this, and obviously this length here is the radius, it's also this one here. If there's an arc length L which equals to R, that means this distance along the circumference, it equals to R, the radius. The angle that this arc subtends at the center of the circle, theta, should be equal to 1 radian. And that's the definition for radian. An angle at the center of a circle that is subtended by an arc length that is equal to the radius of the circle. Let me also say that an angle subtended by the circumference at the center of a circle normally should be equal to 2 pi radians. I should explain this because of how this is necessary in terms of converting angles from degrees to radians and vice versa. Now, if an arc length that equals to R subtends an angle that equals to 1 radian, therefore, what about 2 pi R? That is the circumference of the whole circle. R here is an arc length subtending an angle at the center of 1 radian. What about 2 pi R, the circumference of the circle? We just need to do a cross multiplication of this, and therefore we're going to have 2 pi R times 1 divided by R. The answer is 2 pi radians. And that is a very important part for us to know, that the circumference of a circle normally subtends an angle at the center that is equal to 2 pi. And please understand that this also equals to 360 degrees, because a complete turn again is 360 degrees, which is a complete turn. We're talking about the angle at the center of a circle subtended by the whole circumference of the circle. Well, let me say another statement here, that the circumference of a circle subtends an angle of 2 pi. That's what we've just said. That is 2 pi radians, and also 360 degrees. I've said that. Therefore, that means 2 pi radians being equal to 360 degrees, it means that 1 radian, that is dividing both sides by 2 pi, should give us 360 divided by 2 pi, which gives us 180 over pi degrees. This measure here is degrees. Well, two things that are necessary for us to appreciate. Number one, 1 radian equals to 180 over pi degrees, and that's what we've said here. Another important point for us to know is that 1 radian also equals to 57.27 degrees. What we've done there is we have 180 divided by 22 over 7, or 3.142. So 1 radian should be 57.27 degrees. These are necessary for us to progress with exercise. So now let's turn to an exercise, and there's a question there. Convert the following angles to radians. Leave your answer in terms of pi. And you're given 3 questions: 30, 225, 720 degrees. So turning on to the first one, we're going to say if 180 over pi degrees equals to 1 radian, what about 30 degrees? Well, it's required of us to just do a cross multiplication. 30 times 1 divided by 180 over pi, this one here, and therefore the answer will be pi over 6 radians. 225 degrees. We're going to say that since 180 over pi degrees is equals to 1 radian, what about 225? Again, we do a cross multiplication. 225 times 1 divided by whole of this, which gives us 5 over 4 pi radians. Lastly, as we turn to 7 and 20, we're going to say that since 180 over pi degrees is equals to 1 radian, therefore 720 would be equal to a cross multiplication of that, which gives us 4 pi radians. Now let's turn our focus to another way. We're going to now convert angles from radians to degrees in 2 different ways. We're going to convert the following angles to degrees, and we're given this set of angles written in terms of pi. They are radians, but written in terms of pi. Then we have others which are just numerals. They don't have pi. Now, as we convert, I'm going to say the following. Number one, since 1 radian equals to 180 over pi degrees. Therefore, pi over 5 radians should be equal to, across multiplication, this one times this divided by this, and the answer should be equal to 36 degrees. Similarly, 11 over 3 pi radians should be, we're going to say, since 1 radian is equals to 180 over pi, it means 11 over 3 pi radians should be across multiplication of that, and that gives us again 660 degrees. Turning on to 4 pi, we're going to say if or since 1 radian equals to 180 over pi degrees, therefore 4 pi radians should be equal to 4 pi times 180 over this, and again it's a cross multiplication for this times this divided by 1, and the answer will be 720 degrees. And we just converted an angle like this, only that we're converting from degrees to radians, and now we're converting from radians to degrees. We move on to the last section as we convert now 3 radians. We're going to say since 1 radian equals to 57.27 degrees, therefore 3 should just be 3 times 57.27, which is 171.81 degrees. 2.5 radians should be, again, we say since 1 radian is equals to 57.27 degrees, therefore 2.5 radians should be just 2.5 times 57.27, which is going to be 143.175 degrees. And lastly, 0.58 radians. If 1 radian is equals to 57.27, again we just need to multiply that, and the answer will be 0.58 times 57.27, and the answer will be simply 33.2166 degrees. And that brings me to the end of the lesson on the radian measure and how to convert angles from degrees to radians in terms of pi, and again from radians in terms of pi to degrees, and radians in terms of just numerals like these 3 here to degrees. Please like, subscribe, share. I'll always appreciate. Check out also for upcoming videos. The next one will be about simple trigonometric ratios. Thank you.